Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? I hope everything is going well. Okay, I would like to introduce myself. My name is Helena Puspita. I'm from the Math Education Study Program of University Muhammadiyah Prof. Dr. Hamka. At this meeting, we will discuss the method of trigonometry with the section, definition, sine, cosine, and tangent. Question times. Number 1. The first problem was present with the triangular trigonometric formula. Three well-known trigonometric functions are the sine, cosine, and tangent. In a right-angle triangle, we have sine alpha equals opposite over hypotenusa equals BC over AC. And then cos alpha equals adjacent over hypotenusa, or AB over AC. Tan alpha equals opposite over adjacent, or BC over AB. How to solve a problem like this? Well, I will explain the solution of the question. In the figure on the left, two angles and the length or the sides are indicated. Calculate sine and cosine of angle alpha. Sine alpha is 4 over 5. The formula sine alpha equals opposite over hypotenuse, or BC over AC equals 4 over 5. And then cos alpha adjacent over hypotenusa equals AB over AC equals 3 over 5. B. Calculate sine and cosine of angle gamma. Sine gamma equals opposite over hypotenuse, or AB over AC. The solution is 3 over 5. And then cos gamma equals adjacent over hypotenuse equals BC over AC. And the solution is 4 over 5. The opposite of the gamma angle is AB, and hypotenuse of the gamma angle is AC. So the solution is 3 over 5. And then adjacent side of the gamma angle is BC, and hypotenuse of the gamma angle is AC. So the solution is 4 over 5. Then how can the sine and cosine of 90 degrees minus theta be calculated when sine theta and cos theta are known? Sine 90 degrees minus theta equals cos theta. For the solution is, with the triangular figure, we can find x, point y, and r, where x is x coordinate and y is y coordinate and r is hypotenuse. So the solution is r equals 1. The formula is y over r equals sine beta equals cos theta. R is 1. So this is 1 equals sine beta equals cos theta equals sine beta equals cos theta. The solution is sine 90 degrees minus theta equals cos theta. And then cos 90 degrees minus theta equals sine theta. For the first step, theta plus beta plus 90 degrees equals 180 degrees. Beta equals 180 degrees minus 90 degrees minus theta. Beta equals 90 degrees minus theta. So, the formula is x over r equals cos beta equals sine theta. R is 1, then x equals cos beta equals sine theta. So the solution of the equation is sine theta. Number 2, in a right angle triangle, the angle theta can never exceed 90 degrees. To be able to define the sine, cosine, and tangent for angles greater than 90 degrees, we therefore introduce the unit circle. This is the circle with center 0.0 and radius 1. In this unit circle, we have sine theta opposite over hypotenuse, or y over 1 equals y. Cos theta equals adjacent over hypotenuse equals x over 1 equals x. Tan theta opposite over adjacent equals y over 8. For each angle, the length x and y are sides of a right angle triangle with hypotenuse 1. With Pythagoras theorem, it follows that x squared plus y squared equals 1. Therefore, we have sine squared theta plus cos squared theta equals 1 for all angles theta. Equation A. Suppose sine theta equals A. Find sine minus theta and sine 180 degrees minus theta. According to the formula, this equation can be answered based on existing formula. So the solution of the equation is sine minus theta equals minus sine theta. Sine 180 degrees minus theta equals sine theta. And then B, find cos minus theta and cos 180 degrees minus theta. Give that cos theta equals B. Cos minus theta equals cos theta. Cos 180 degrees minus theta equals minus cos theta. Number 3. In the unit circle, angles are often given in radians, and angles of 1 radian is the angle you have to make to describe an arc with length 1 on the unit circle. When using a calculator, make sure you know whether it is set on radians or degrees. The equation is the circumference of the complete unit circle is 2p. A. Calculate the exact number of degrees that corresponds to an angle of 1 radian. Step 1. Radius equals r over r. And then the circumference is 2 times p times r. Then radius is 2 times p times r over r equals 2 times p radius. So the solution is one full circle is 360 degrees. 360 degrees is in degrees, which means if in radians. One full circle is 2p radians. 360 degrees equals 2p degrees radius. Then we divide each other by 2. Thus becomes 180 degrees equals p radius. So the solution is 1 radius equals 180 degrees over p. And then p equals 22 over 7. 1 radius 180 times 7 over 22 equals 630 over 22 equals 57.27 or 57.3. B. Express 60 degrees and 90 degrees in radians. 60 degrees 180 degrees equals p radius. So 60 degrees equals 60 degrees over 180 degrees. P radius equals 1 over 3 p radius or p over 3 radius, because 1 times p equals p. So the solution 60 degrees equals p over 3 radius. And then 90 degrees equals 90 degrees over 180 degrees. P radius equals 1 over 2 p radius or p over radius. Then the solution is 90 degrees equals p over 2 radius. Next question, number 4. Below two triangles are pictured. Triangle ABC is equilateral and triangle PQR is a right angle isosceles. In this triangle, the sine and cosine of 30 degrees, 45 degrees, and 90 degrees can be found. Here we will look for the value of the edge or the height of the triangle. To calculate the height of the triangle, we can use the Pythagoras theorem. Is height square equals hypotenuse square minus pedestal square. Each is CD lines. CD square equals BC square minus DB square. BC minus DB. CD square equals BC 2 DB 1. And then CD square equals 2 square minus 1 square. CD square equals 4 minus 1. CD equals square root 3. So each is square root 3. Use this to calculate the cosine and sine of 60 degrees and 30 degrees. Cos 60 degrees, the formula cos alpha adjacent over hypotenuse, or AD over AC. Then cos 60 degrees equals 1 over 2. And then sine 60 degrees, CD over CA equals each square root 3 over 2. So the solution is sine 60 degrees equals square root 3 over 2. Cos 30 degrees, CD over CA equals square root 3 over 2. Sine 30 degrees, AD or adjacent over hypotenuse, AD over AC. So 1 over 2. We find the solution is 1 over 2. And then calculate Q and the cosine and sine of 45 degrees. Q is PR line. Q, PR line. So PR square equals QR plus PQ square. PR square equals 1 square plus 1 square. And then PR equals square root 2. See, cos 45 degrees. The formula cos alpha equals adjacent over hypotenuse. So cos 45 degrees equals PQ over PR, or QR over PR. The angle. And then cos 45 degrees equals 1 over 2. 1 over 2 times square root 2 over square root 2. We find the solution is cos 45 degrees equals square root 2 over 2. Because 2 times square root 2 is 2. And then formula sine alpha equals opposite over hypotenuse equals QR over PR. Q is square root 2. And then sine 45 is 1 square root 2 equals 1 square root 2 times square root 2 over square root 2. Sine 45 degrees equals square root 2 over 2. Next question. Number 5. The exact values we found on the previous page can be found several times in the unit circle. These other intents fall from the rules you deduce on page 2 and can also be deduced from the figure on the right. The rules from page 2 are also summarized in the table below. With these rules, even more exact values can be deduced. See this figure. We have the formula and trigonometry table. So the solution, sine angle 0 is 0. Sine alpha 0 degrees is 0. Cosine 0 is 1. And then 1 over 6p sine 1 over 6p equals 1 over 6. P is 180 degrees. So 1 over 6 times 180 degrees equals 100 degrees over 6 equals 30 degrees. So sine 30 degrees is 1 over 2, and then cos 30 degrees is square root 3 over 2, and then tan 30 degrees is square root 3 over 3, or 1 over square root 3. Next, 1 over 2p equals 180 degrees over 2 equals 90 degrees. Sine 90 degrees is 1. Cos 90 degrees is 0. And tan 90 degrees is not defined. And then angle 2 over 3p times 180 degrees over 3 equals 120 degrees. So sine 120 degrees is square root 3 over 2, or 1 over 2 square root 2. And then cos 120 degrees equals minus 1 over 2. Tan 120 degrees equals minus square root 3. Next, 3 over 4p equals 3 times 180 degrees over 4 equals 135 degrees. So sine 135 degrees equals square root 2 over 2. Tan 135 degrees equals minus 1. Cos p is p 180 degrees. So cos p is cos 180 degrees equals minus 1. Tan 180 degrees is 0. Next, 1 times 1 over 4 is 5 over 4. 5 times p, or 180 degrees over 4, equals 225 degrees. Sine 225 degrees equals minus square root 2 over 2. Cos 225 degrees equals minus square root 2 over square 2. And 225 degrees equals 1. And then 1 times 5 over 6. 1 times 5 is 5 plus 6 equals 11 over 6. P is 180 degrees, so 11 times 180 degrees over 6 equals 330 degrees. So sine 330 degrees equals minus 1 over 2. Cos 330 degrees equals square root 3 over 2. And then tan 330 degrees equals minus square root 3 over 3. Next, equation number 6. For many angles, it's impossible to find exact values for the sine, cosine, and tangent. In such cases, you can use the function sine, cos, and tan on your calculator to find approximate values for the sine, cosine, and tangent. You can also use the function arcsine, arccos, and arctan to find the angle corresponding to a certain sine, cosine, or tangent. There are two things to keep in mind while using your calculator. Make sure you know whether your calculator is set on radians or degrees. For each value of the sine, cosine, and tangent, there are two corresponding angles between 0 and 360 degrees. Your calculator returns only one of these values. In some cases, you have to calculate the other one yourself. Okay, the question A. Find in two decimals angles in degrees are indicated with a degrees. For this question, it can be solved using active devices such as calculators because are easier to calculate. So sine 2 equals 0.90 radians. Cos 7 degrees equals 0.99 degrees. Tan 5 equals minus 3.38 degrees. The question B. Find alpha in radians on two decimals such that sine alpha equals 3 over 4 and minus 1 over 2p less than alpha less than 1 over 2p. Sine alpha equals 3 over 4. Alpha equals 48.59 degrees. And then radius is alpha times p over 180 degrees equals 48.59 degrees times p over 180 degrees equals 0.85. So the solution is alpha equals 0.85. Next question number 7. To find the sine of, for example, alpha plus beta, you can use the formula for sums and difference of sines and cosines. The formula. These rules can be deduced from one another by filling in smart expression for alpha and beta. Therefore, we only have to prove one of the rules. To prove them all, a proof of the bottom equation can be found in the step proof. To deduce the rule for the sum of cosine, fill in minus beta. instead of beta. That leads to is the formula. Next, the question A. Give formulas for sine 2 theta and cos 2 theta. Step 1 is sine theta plus beta. Sine theta plus beta. The formulas equals sine theta times cos beta plus cos theta times sine beta. And then sine theta plus theta equals sine theta times cos theta plus sine theta times cos theta. So sine 2 theta equals sine theta times cos theta plus sine theta times cos theta. So the solution is sine 2 theta equals 2 sine theta times cos theta. Next, cos 2 theta. Cos 2 theta equals cos square theta minus sine square theta. In the trigonometric identity formula, cos square theta equals 1 minus sine square theta. So, cos 2 theta equals 1 minus sine 2 theta minus sine square theta. Sine 2 theta equals 1 minus sine square theta minus sine square theta. Cos 2 theta equals 1 minus 2 sine square theta. So the solution is cos 2 theta equals 1 minus 2 sine square theta. Next, calculate sine 2 over 12p. P is 180 degrees. Sine 7 over 12 times 180 degrees equals 105 degrees. Sine 105 degrees equals sine 45 degrees plus 60 degrees. And then sine 45 degrees times cos 60 degrees plus cos 45 degrees times sine 60 degrees equals 1 over 2 square root 2 times cos 60 is 1 over 2 plus cos 45 degrees is 1 over 2 square root 2. Sine 60 degrees is 1 over 2 square root 3. So 1 over 2 square root 2 times 1 over 2 plus 1 over 2 square root 2 times 1 over 2 square root 3 equals 1 over 4 square root 2 plus 1 over 4 square root 6 equals 1 over 4 times square root 2 plus square root 6. So we find the solution is 1 over 4 times square root 2 plus square root 6. I think that's all. Thank you for your attention. Hopefully it will be useful for us. Wassalamualaikum warahmatullahi wabarakatuh.